That's what I want us to take note. Now I can begin from the first bit, because we are saying what you'll be given here is an acceleration which is given by 4t minus 13 meters per second square. So that's what you'll be given. So now, meaning that for us to be able to get this velocity, we have to we have to integrate. So we are going to take v. V will be equal to the integral of acceleration with respect to time dt, and then this is what we're going to have here as the integral 4t minus 13 with respect to time. So if we can integrate this one, it becomes v is equals to 4t squared divided by 2 minus 13t minus 13t plus a constant which is c. From the rules of integration, we add a constant which is c. And then, because we've been told that when the initial velocity of the particle was 18 meters per second, that one means that initially, at the beginning, we have a velocity of 18 meters per second square. But at v is equals to 18, that one means time is equals to 0. So at v is equals to 18, time was equal to, because it's initial meaning at the beginning of the timing of this particle. So time was 0. Now this one means if we can work it out here, remember this one is 1, this is 2. So then we are going to have, v is equals to, now we want to get the equation of velocity, expression of velocity. Remember, if we want to have an expression, then we have to drop that constant c. We cannot have an equation where we have got this constant c. So we must remain with v and the one which is with respect to time. So meaning, in this case here, we are going to take this v and get the value of c, and then now we substitute it here to get the equation of velocity. Now this one means that we're going to have this one to be 2 times 0 squared, because we are saying that at v is equals to 18, t is equals to 0. So this one is 0, 0 squared minus 13 times 0 plus c. So meaning our c is equals to 0. So from here, it goes that our equation becomes v is equals to 2t squared minus 13t plus 18. So this one becomes the equation for velocity. Now the question is saying you determine the value of t when the particle is momentarily at rest. So when the particle is momentarily at rest is that time where v is equals to 0. So at any time where that particle, for example, if it's oscillating up and down, at that point where it reaches the maximum point, that's where the particle is at rest, where v must be equal to 0. Assuming that now you are running forward, now that time that you're going to start coming back, your speed must be equal to 0. You cannot run and then you turn back with some speed. You have to go to 0. And that's why we're saying that at this point here, where the particle is momentarily at rest, then time t or v should be equal to 0. So we are equating our equation here to 0. So we say we're going to say at v is equals to 0, then we equate our equation here to 0. So we're going to have 2t squared minus 13t plus 18 is equals to 0. So we equate our equation here to 0 because that's where we're going to have that particle momentarily at rest. From here we can think of two numbers. Product is equal to the this and this, which is product is equals to 36 and the sum is equals to negative 13. And the two numbers are 9, negative 9 and negative 4. So if we can use the two numbers there, we're going to have 2t squared minus 9t minus 4t plus 18. So if we factor it out, then we're going to have t into 2t minus 9, and again this side 2 into 2t minus 9. So this one, if you group them, they're going to be t minus 2 and then 2t times 2t minus 9, which is equal to 0. In fact, we should be equating this one to 0. This is equal to 0. It's equal to 0. And then this one goes that t minus 2, so this one the same as the time at that point where the particle will be momentarily at rest will be equal to time is equals to 2 seconds, or time is equals to 9/2, which is 4.5 seconds. So we have got two instances at which this particle will be momentarily at rest. Like, just assume that like we have a ball which is bouncing up and down. So at that point where it's going to be at maximum height, at where it will be turning back, that's the time that we're going to have it at rest. It must come, it must have a velocity of 0 for it to be able to turn back. And that's why, as you can see, this particle, it's moving like the same kind of bouncing up and down. So after 2 seconds, it's going to be at maximum height, or going to be turning, and again at a point where we have what, after 4.5 seconds, again it's where it's going to be turning back. So at that point, we say the particle is momentarily at rest. Now the second question on the same, we find the distance covered by the particle between the time t second is equals to 1 second and t is equal to 3 seconds. I want us to have a look at this question in a way that we talking of t is equals to 1 second to t is equals to 3 seconds. And I want to say that this is where we have got a definite integral, meaning we don't need to, after we going to get this displacement, in fact, you can work it out very fast. S will be given by the integral of v with respect to time. So, which, if we can have it down, because our equation is what we got here, so we can have it as the integral over 2t squared minus 13t plus 18 with respect to time. So, which gives us, so S will be equals to, this is the same as 2t cubed over 3 minus that t squared over 2 plus 18 plus a constant c. Now we are supposed to get the distance covered between t is equals to 1 and t is equals to 3. So for us to be able to get that distance, remember, this is just like a particle which is taking some kind of a motion, which at times it can be on the other side of the axis, and the other, at some other points can be on the lower side or the upper side of the axis. So meaning the area may not be above the x-axis or even below the x-axis. At times it can be above, at times it can be below the x-axis. Now, for us to be able to any question of this type, then I'm just asking, or I'm giving this as a note that students, whenever you solve these questions, you must check first before you can do your calculations. So because the question is demanding you to calculate from t is equal to 1 second and t is equal to 3 seconds, then what you must do, just come and sketch that graph motion so that you can be able to see is the area above the x-axis or below the x-axis. Like for me, I'm just going to have the values here. So I'm going to have the values of t, because t is 1 second, 2 seconds, and 3 seconds. And then now I get the corresponding values of v so that I can plot the graph. Now my equation of v here is 2t squared. So we have got 2t squared minus 13t plus 18. So if we substitute 1 here, then it will be 2 minus 13, 2 minus 13 plus 18. So 2 plus 18 is 20, 18 minus 13 is 7. So this first one becomes 7. Now if we substitute 2 here, then here will be 4 minus 26. This is 4 times 2, which is 8. So if we subtract that one, this one becomes 0. And then the next one, if we substitute 3 here, it will be 2 times 9, which is 18. So it will be 18 minus 13 times 3. So, this one, 39, which is okay, and then plus 18. So if we worked out this 18 plus 18, which is that's 6 minus 39, so which becomes negative 3. So meaning here, we have got negative 3. So if we can have a sketch of that one, then this just like, if we have got, this one the axis, this is x-axis, and this is y, then this area, if we can give this point here to be 1, this one to be 2, and this one to be 3, then as you can see at point 3, we are having v being negative. Now at this point here, we have at 1 we have got, which is 7. So if we can mark points at random, then we can have something of this kind. So meaning our region, our area, should be something of this kind here, this graph. So if we can shade it, then this is what you're going to have. So as you can see, from 1 to 2, the area is above the x-axis. and from 2 to 3, the area is below the x-axis. So if we can now integrate from 1 to 3 direct, then that one may not give us the correct answer because one area is on the lower side of x-axis. And whenever we are subtracting, we cannot take this one to be a negative value because area should be a positive value. So even if we calculate and get the negative ones, then we just assume that or ignore the negative so that we have it as positive. And even let's just see the ways we can solve this question. So meaning our area now here should be from this what we've gotten here should be from just get my pen ready. Now it should be from, so it should be, this one is 2t cubed over 3 minus 13t squared over 2 plus 18 plus c. Now this c, because we're going to subtract again, it's going to be 0 because this is a definite integral. So whenever we have got limits, that one becomes a definite integral. So by the end of the day, if you subtract, that c becomes 0. So you can even live up with that c. So meaning we can stop at that point. But now this one should be from. Now we're not going to have it from 1 to 3. At any time you solve this question, check first the way I've checked here, so that you see if the area is on the same side of the axis. That one you can work out direct from 1 to even that number which you'll be given. But now for us here, there was a trick. You have to check any question where you integrate and you've been given definite integral, finding the distance covered. You have to check. You have to check and see if the areas are on the same side of the axis. Like my case here, two sides. So I have to work out the area above and I add the area below. So I'm going to negate from 1 to 2, because as you can see, this is where the area is going on the lower side. And then I'm going to add again the same from 2t cubed over 3 minus 13t squared over 2 plus 18. But now this one now will be from 2 to 3. So that after I've worked out this question, I'm now going to add the two areas. So if I add the two areas now, I'm going to get the very accurate answer. So make sure that you check first before you can proceed. Yeah, so make sure you check first. You don't proceed if you don't check. Otherwise, you're going to get your own personal answer. So make sure you check. Now, if you can begin with the first one here, we can work out this one first. We get the answer and then now we add with this one. But what we're going to see, the answer for this one should be a negative one because it's below the x-axis. The answer should be negative one, but we're going to check that one from the workings. Now we can come and substitute the values here. So we are saying it's 2. So it is 2. If we start with the 2, then it will be 2 into 2 power 3 divided by 3 minus 13 over 2. This is 2. And then here we square plus 18 plus 18. That's what we have. So this one should be subtracted with, we're going to subtract. Now substitute with the 1, so it will be 2 over 3 into 1 cube minus 13 over 2 into 1 square plus 18. So I want someone to work it out. Let me just use my calculator here, work it out. So this one will be equals to 15 1 over 3 minus 12 1 over 6. So if you subtract that one, the answer becomes 3 and 1 over 6. 3 1 over 6. So this one becomes the area for this part from 1 to 2. So this area here. And remember that the area of the curve, the same as the total distance covered. So you can take note of that one from even linear motion from 2 mathematics. That's what we discussed. Now the second bit, now we're going to get the area from here to here. So the same equation, you pick it this way. Now 2 over 3t cubed minus 13 over 2t squared plus 18. Now it will be from 2 to 3. So we're going to get the area of the one below the x-axis. Now if you again substitute the 3, then this one will be the same as 2 over 3 into 3. We have got cubed there minus 13 over 2 t squared. So our t now is 3 squared plus 18. So this one you subtract it from where we have 2. So 2 over 3 into 2 cubed minus 13 over 2 into 2 square plus 18. So if you work it out, then this one will be giving us, so if you work the first part out, you are going to get 27 over 3. So you're going to get, let me just check that one using the calculator here. So that part is going to give us 27 over 2. 27 over 2. And then you subtract with the second part is the same as the one that we used here, because here we have substituted the 2. So we can come and pick this value here, which is 12 and 1 over 6. No, 15. It should be 15, 1 over 3. It should be 15 and 1 over 3, because that's what you had calculated with after we substituted with the 2. So if again you can solve that one, the answer is going to be -1. Let me just check that answer. 5 over 6. Now, the reasons why we are getting this negative is because the area is below the x-axis. So that negative you ignore, because the area can never be negative. So that negative you ignore. And then now, for us to be able to get the total area of this one, because the question says the distance covered from time 1 second to time 3 seconds, then you have to add the total to get the total area. So the area above and the area below. So you're going to take 3, 1 over 6. So distance 3, 1 over 6 plus 1, 5 over 6. We have agreed that we assume this negative because the distance cannot be negative. So it's only the direction which makes it be negative. Now, if you add this one, you get 5 meters. So meaning the distance covered should be 5 meters. Thank you for watching this video. Make sure you subscribe to my YouTube channel, Jules Osoro, and follow me, comment. Yeah, so that's what I'm requesting. You have a good day. Thank you for watching. Thank you for listening to me.